Hi and welcome to our last part of our webinar series about robot-based 3D printing. If you didn't see our first or second video, you can watch them on our YouTube channel. My name is Werner, I'm a research engineer here at the Austrian Center for Digital Production. My work areas include software development, circuit design and additive manufacturing technologies. In this webinar I will talk about another showcase we have done, repairing metal parts. Here are today's topics. First, I will describe the problem about repairing or recycling metal parts. Then I will talk about the solution to this problem. I will give you a short overview about wire arc additive manufacturing. And next, I will explain our workflow. And last, I will show you an example. So what is the problem about repairing or recycling metal parts? Repairing a damaged part can be highly complex and is unique to every single part. Therefore, it is very difficult to automate a repairing process with conventional manufacturing methods. Recycling is therefore the chosen option, but it takes a lot of energy to do this. In result, it is just cheaper to throw the broken part away and buy a new one. But how can we solve this problem? The answer to this is additive manufacturing. Wire arc additive manufacturing helps us solve this problem by giving us a toolset to repair metal parts in an easy and cheap way. Wire arc additive manufacturing, or short WAM, is a production process used to 3D print or repair metal parts. It belongs to the direct energy deposition family of additive manufacturing processes. So basically, WAM is executed by deposition layers on top of each other until a desired 3D shape is created. The production of parts using WAM is carried out by an industrial robot equipped with a welding torch. The welding torch is used to melt the wire feedstock to build 3D parts. Here you can see the basic steps of our workflow to repair any part. First, we need to scan the damaged part and generate a computer model. Second, we need to generate the welding path to repair the part itself. And lastly, the welding robot uses the generated welding path to reapply the missing material. We developed a software solution that can create the welding paths fully automatically. It is programmed in Python and has a modular design so it can easily be adapted to other use cases. Here you can see our example part, a large gear. On the right picture you can see in red the damaged part of the gear and in green the undamaged part. The output of our software looks like these two pictures. It calculates the missing material and generates welding paths to replace it. The result is a repaired part that has the same shape and mechanical properties of the original undamaged part. Our solution is much cheaper and better for the environment than recycling the broken part. This concludes our last webinar about robot-based 3D printing. Thank you for watching. I hope you enjoyed it. You can follow us on LinkedIn, Twitter and Facebook. We also have other webinar videos about a variety of topics on our YouTube channel. If you have any questions, feel free to contact us. Have a nice day.